So here we go. We're going to talk about ionic covalent bonds. We're also going to talk about metal bonds and polyatomic ions. But let's start with the ionic bonds. Ready? Okay, group one. Remember we talked about group one? They have one valence electron. They like to become cations of +1. So, hydrogen each likes to become a plus. That's an example. I'm going to flip over so I can grab. There we go. So hydrogen, lithium, sodium. All those guys are just 1+. Because they are so eager to get rid of that spare electron. Okay. Then group 2. They like to form a 2+. That is barium. Barium, magnesium, calcium. Yes, there are more of those than that. All right, does that make sense? Okay. Then on the other side, you've got your group 17. You okay?
No, I'm just a little tired.
Okay. Maybe you can stand up again. No problem with that, as long as you're not blocking anyone's view. All right.
Too lazy to sleep.
Well, the laziness I can't help. F is minus, Cl is 1 minus, and bromine 1 minus, iodine 1 minus. You get the picture on that one. Group 16. And those are the nonmetals, by the way, that are forming these ions. Group 16 is 2 minus, so you're going to have oxygen is a 2 minus, sulfur 2 minus, and selenium, yes, 2 minus. Makes sense so far? Yes, maybe so. Okay. Group 15. These like to form 3 minuses, so that's nitrogen and phosphorus. 3 minuses. You notice I did not include the semiconductors or the transition metals that are in those groups, okay, because they behave slightly differently. Metalloids can go either direction. They can be, and then the transition metals only like to be in the CO electrons usually. Occasionally you'll get them to form an ionic bond, but not often. All right, good so far. All right, so what happens with ionic compounds is you're going to take guys from these groups and match them with guys from these groups. Your group, your whole compound needs to be neutral. Does that make sense? All right, so let's take somebody from group 1, say hydrogen, and
So
yes,
all the groups are not in order.
yeah, I know. They're in order from outside in. Let me not use hydrogen. Let me use potassium instead. All right, so I'm going to take an example. Here's potassium. He's 1+. And I'm going to combine it with, say, fluoride. All right, potassium is a 1+, fluoride is a what? 1 minus, okay? So 1+, 1 minus, does that give me neutral? All right, so that would just be KF. Board?
Oh, no.
Good. Smart answer. All right, let's try with potassium and oxygen. Oxygen is 2 minus, potassium is 1 plus. Is that neutral? No. What do I need to do to make it neutral? Yes. Mm-hmm. Then you put a 2 here, and you have 2 potassium now. So 2 potassium will now balance out my 1 oxygen. Let's try potassium with nitrogen. Is that neutral? No, what do I do to balance it out? Mm-hmm. Over here for my 3 plus. So, when I'm done, I have KF, I have K2O, I have K3N. Does that make sense to you? Yes? No? Yes, this is your paragraph class too. Does this make sense to you guys? Okay, let's try group 2. So I've got BE. Let's combine it with fluoride. So I've got 2 plus and I have a minus. Is this neutral? Well, what's 2 plus minus 1 negative?
1.
Yeah, just 1 plus. Is that neutral? No, which means I need to do what? Yep, I need 2 of the fluoride now. Yes, you did.
But you didn't say anything, you just kept yakking on.
Oh my goodness.
I was trying to get the others to engage. But yes, you did say that.
Good job.
But you said excellent. Alright, so I've got BE, it's 2 plus, 2 minus. Is this neutral?
Yes.
That's nice. I don't have to do anything with it. Alright, and then BE, and N. So BE is a 2 plus, N is a 3 minus.
No, it's not. 3 plus.
I've got a minus, right, when I put them together. What do I need to do to make it balanced?
3 plus.
Yep, I need 3 of the pluses and how many of the minuses?
To make it neutral?
Mhm.
3.
3 here, and how many here?
3.
3 times 3 is 9, so I'd have 9 minus, and I'd have 6 plus.
Wait,
4?
so you need 2.
I need 2. 4 was a good guess, but I need 2 of them. So 3 times, and this is a trick to these guys, you can switch, so whatever this sign is and this sign is, you switch. So this is 3, we go down here, this 2 would go down there. And it actually makes it balanced, which is kind of fun. Good job. Alright,
Yeah, bro, that's exactly what it is.
so those would be the ones we ended up with. Alright, does that make sense?
Yeah.
Okay. So these are ionic compounds that we just formed from our various groups and the combinations. This is probably going to be the one that be the most pain. Alright. Let's talk about covalent bonds. Now, remember ionic bonds are forming ions. Covalent bonds, what are they doing? You guys remember what they're doing? Covalent bonds? And you remember what covalent bonds do? You give up electrons or take electrons, those do what with the electrons?
Twist.
Not close. They share. Sorry.
They said together, just like you and me.
Well, no, because in that case, one has food and gives it together and you consume it. So in that case, you guys have an ionic bond.
I'm a supplier, Kevin.
A covalent bond would be like Lady and the Tramp and the spaghetti strand.
Yes, me and you.
They both can do this.
Yes, it can. When there's a will, there's a way, Gavin.
To some extent. There are physical limitations. Alright, so covalent bonds are sharing electrons. So, ions. So ions form compounds.
They're sitting around.
And atoms share.
You want help in dumping and bumping them?
Alright,
That's so you can get your student.
I have you and him. others currently. Alright. Sharing electrons. This is where we need to know your valence electrons. Let's do O2. O2 is oxygen in its native form. How many valence electrons does oxygen have? Yes, you can grab a book from there.
City.
Valence electrons for oxygen.
14.
14 is its atomic
Oh.
number.
7.
Correct. 7 is how many I have on the outside. So remember, you look at the groups and see which one. So this one has 7
No,
electrons.
it's 8. Oh, I read the wrong thing. It's 8.
No, you're right. It's 7. It wants 8,
Oh.
but it has 7 currently. All right. So I have 2 of these oxygen, so I'm gonna draw 2 of them. And this guy has 1. We put electrons around it. You can imagine that you've got a square like this. So I put 2 electrons on this side, 2 here, 2 here, and 2 there. Does that make sense when I'm laying them out? This is electron dot structure is what they call it. And I always start right here on this side, and I go counterclockwise. So there's 1, 2, 3, 4, 5, 6, 7.
6, 7.
Right? Because 7 valence electrons. Does that make sense to you
Just had to
guys?
do it.
Alright, I'm gonna do the same thing with this one, only this one I'm gonna use dots instead of X's. So I've got 1, 2, 3, 4, 5, 6,
7.
No!
6, 7.
You do this on purpose every day.
You know what's funny?
What?
Your voice is gonna come across on this recording much louder than mine. Alright, do you understand that I've got 7 electrons, 7 electrons? Do you see how this guy is missing 1? Right here. This guy is missing 1 right here. How many electrons do they want total? 8, okay? So what I'm gonna do is I'm gonna take this guy, and I'm going to have them share. This guy's gonna share his electron with him, and he's gonna share his electron with him. Does that make sense? Alright, so, I'm gonna put them next to each other. Those are the ones that are gonna get shared. So just taking them and shifting them, and then everyone else. And the reason why I'm doing the dots and the X's is so that you can see where it came from, or who gets what. Does that make sense? There you go, like that. Okay, so if I look around this oxygen here, how many electrons does he have?
6, 7.
7, and now he's got 1 from here, so now he has 8, okay, so he's happy. How about this guy? How many does he have?
8, 7.
7 plus the 1 from this guy, which means he has 8.
Oh, yes.
So he's happy too. Does that make sense? 1, 2, 3, 4, 5, 6, 7, 8. And he has 1, 2, 3, 4, 5, 6, 7, 8. And the reason why they can do it is because they're sharing these 2.
You're doing this on purpose.
Does that make sense?
Yes.
Alright, so this is the electron dot structure of how I do it, and because they've got these 2, I can actually do it in a bond structure like this. I can turn that pair of electrons in the middle to be dots, and then I just include these guys. Although once I have the bond in, I can just make these guys dots. That's fine too, because I know who they belong to. I don't have to worry about, like in this case. Does that make sense? Okay. So that's a covalent bond. Let's do another covalent bond. CH4. How many valence electrons does carbon have? You closed the
I
book.
really just saw it too.
Yes, you did.
6.
6 is its atomic number, that's correct. What is the valence electrons? So 12 is the mass. What group is it in?
14.
There you go. Group 14, which means it has how many valence electrons?
4.
There you go, 4, very good. All right, so I've got carbon with 4 electrons. 1, 2, 3, and 4. Hydrogen, how many electrons, valence does hydrogen have? Which part's confusing? Okay.
1.
1, okay, so he only has 1. And there's 3 of these guys, so 1, 2, 3. It's a part of investing. Cute. Alright, so I've got carbon here and I've got 4 of these guys. Does that make sense so far? Okay. So, how many electrons does carbon want to have in total? It wants 8, okay? Right now it has 4, okay? These guys want to have how many? Good guess, it's 2. Remember, hydrogen and helium always want 2. They're the only ones who want 2, everybody wants 8, except for these guys. Alright, so do you see how I could take a hydrogen, put 1 here? I could put hydrogen, put 1 here, it would share electrons, so it would have 2, carbon would have 1 more. I fit 1 here, and 1 here, and 1 here. Do you see that? Alright, let's do it. So carbon with my 4 dots. Hydrogen here. Translation just took place and light just came on. That's wonderful. I love it. Okay.
That's enough.
So 2 over 6. So carbon is having hydrogen.
So they're both gonna be happy.
Yeah, so they both get what they want.
You get it?
We'll get there. Alright, hydrogen wants to have how many in total? 2, right? Alright, now that I have these arranged, how many does this hydrogen have?
2.
It's happy, yay. How many does this hydrogen have? And this one? And this one. So are the hydrogens happy?
Yeah.
Alright, now let's deal with carbon. Carbon wants how many?
8.
Alright, how many are in here now? 8. Does that make sense? 1, 2, 3, 4, 5, 6, 7, 8.
No.
Everybody's happy now. Because they're sharing hydrogen's sharing their electron with carbon. Does that make better sense, Angela? They're all sharing. You could say no if it isn't. We'll get there. I'm going to do another one for you. That'd be a little strange.
I didn't know why you have all that on there.
How do you manage to get Disney Plus on the school Chromebook?
It's not school.
It's not, it's his own.
Are you serious? No
Yes.
way.
Yes, it's mine, it's trappy.
No way, this is yours.
Alright, so Kingston, you're distracting the whole class and me. Let's not do that.
So it's not.
Okay, so we've got, are you looking up to see?
Yeah.
Sorry, Angela.
Ooh, club.
Or Grace or whoever. Alright, so everybody's happy because carbon now has 8 because it's sharing 4 electrons with hydrogens, with 4 hydrogens. And all 4 hydrogens are happy because they get to share one of the carbons. Alright, so that's covalent bonds. Let's do another one just for the fun of it, carbon dioxide. You guys know what that is? Alright, carbon has how many valence electrons? Surely goodness and mercy. May you dwell in the house of the Lord forever. Amen.
You said, what is it again?
How many valence electrons are on carbon?
Carbon.
We've done it already.
6.
That's the atomic
Four.
Oh
number.
my goodness.
4.
4. Alright, so I've got carbon with 4.
And oxygen has,
It gets
has
tricky.
7.
Correct, oxygen has 7. I've got 2 of them.
Don't you dare say that number yet.
3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay. many do these guys want?
It's 8.
8 total, so they want 1 more, so they're gonna take that from carbon, and carbon wants how many? 8, okay, so let's see what we can do for this guy. I've got carbon here, I don't think I need to grab onto myself, thanks.
Come on, Gavin.
I'm not Gavin, but okay. 1, 2, 3, 4, 5, 6.
Oh, don't you dare, dang it.
2, 3, 4. 1, 2, 3, 4, 5.
No, please.
6, 7. What's the assumption with the?
I'm sick of it. It's annoying. You say the same BS every single day.
Remember what BS
Do you not get
Alright,
tired?
Kingston, we need to focus, please.
Remember what BS stands for?
Alright,
Yep, sure do.
yeah, we're not, that's not appropriate, and
It's not appropriate, Gavin.
I am recording.
Oh, no.
Okay, so back to this. I know my 2 oxygens are happy, right? However, is my carbon happy? Not really, okay? How many is it missing?
2.
Yeah, it's missing 2 more. So this is what's gonna happen. These guys, this one's gonna come over to this side.
I'm recording, by the way.
Yeah, I know.
And
That's free reign.
one of these is gonna come here.
No, you missed everything.
I do not miss Gary, but you never mentioned his name.
Gentlemen. Okay, so carbon is gonna have 2 of these here. And I'm gonna put this guy here. Alright, so I'm moving the 2 that were on the carbon to here and here. And now what's gonna happen is oxygen is gonna take one of these electrons and it's going to match. Like that. Does that make sense? So, what's happening, oxygen is still happy, 2, 4, 6, no it's not, there we go. Now, oxygen's happy, 2, 4, 6, 8. Alright, so basically it's shifting over here,
Oh, you're
so
gonna connect this together.
this 8 and 8, I still have 8 and 8 for my oxygens,
Uh-huh, and you're gonna connect them.
and then my
Yeah.
carbons are gonna have 8 now. There's just double bonds between the oxygen and the carbon. Does that make sense to you guys? Okay, so he's sharing 2 pairs of electrons, so when I do the structure, it's gonna look like this. With the lines for the bonds. And these guys will have 1, 2, 3, 4, 1, 2, 3, 4. Does it make sense? Okay. So basically we're rearranging just to see, make sure everybody has their 8 so everyone's happy. Okay? 2 other sections we need to cover. Metallic bonding, we've already talked about that briefly.
Wait, is there more for today?
Remember I said we're talking about the 3 types of bonding. We've already talked about metal bonding where you have the sea of electrons around the nucleus, okay? Do I need to go over that again, or are you guys good with the metal bonding? Maybe I'll draw a picture up. Are you gonna become a nurse?
He got real bad eczema on his elbows.
Okay. You become a nurse practitioner?
We'll go crack desert.
Or a dermatologist?
I don't know.
Too much work?
I don't, you said don't. Maybe.
Okay, something to consider.
I don't know. Like lately, well since, it was like 2023, like having a real big tech,
Okay.
like the iPhone, you know what I mean, other stuff. I don't know, it looks cool, like it looks fun, you know? the building will happen.
No, man.
What do you mean, no?
Things apples.
Dude,
You see him see on the street.
you
Hey,
lit-
fix anything?
Okay.
You literally detail cars, gang. You're not gonna make
No,
them.
I'm gonna be a physical therapist.
Physical therapist, yeah, good luck with that, big bro.
Actually, that's a good job.
Thank you.
Physical therapist.
Mm-hmm.
Yeah, I'll be the first one there again to make her left away from hell.
Unfortunately for you, fortunately for him, he doesn't have to accept you as a patient.
Mm.
Alright, so basically
Yeah,
what's
I'm gonna
happening
put you
here
through, I'm
is you've got these
stretching you out.
nuclei in here. Alright, and they're all positives, depending on what it is, 2 positive, 3 positive. And these are all your little electrons running around. Not like that. Okay. And what happens is, when I add an electron to this system, it bumps it all the way through, and it bumps out an electron on this side. That's why electricity is able to flow. You're pulling in, or you're pouring in electrons, and they just get pushed out the other side. It's like, what's an example? Like a water hose. So I put water in one end, and it just pushes the water through the hose out the other. I'm gonna do that kind of demonstration. Alright, so those are metal bonds. The other thing you guys need to be aware of are polyatomic ions. Do you know what poly means?
Many?
Yep, many.
So polygon means many lines.
Many gons, their size. Atomic. Atoms. So polyatomic ions are ions that have more than one atom to them. For example, hydroxide.
Oop. What happened?
Some again.
I don't got
She's like, no, no.
Oh,
What?
man, just give it up.
I always gotta say something. Keep your mouth shut, boy.
I would have found it eventually. You tend to forget your shit.
I can't help it, Miss
Be
Williams.
more sneaky next time. That's
You
it.
can be.
I
help it.
can.
And I need
I love-
your package of gum.
I don't have that. I got some from my
Obviously, you
mom.
had some.
No, I have some from my mom.
But you brushed your teeth in between. So you're telling me you took the gum out, put it someplace while you brushed your teeth, and put it back into your mouth.
Yo, she's clocking you down, bro.
No. I had some in my pocket. I forgot. So, yeah.
He's using old gum.
Oh, shut up. No, I'm not.
That's what I'm
Pipsqueak.
hearing.
No.
Oh, can you kill that?
Killing's a little extreme.
She knows what I mean. Yes, you're right. Oh dear. Alright, so that's one polyatomic ion. We have, let's see. OH, I have CO minus. I have CN, but that one is a minus as well. Yep, CN minus, cyanide. So if you look on the page 219, you will see I have a whole list in figure 10 of common polyatomic ions. Okay. So basically what's happening with these guys, the oxygen and hydrogen are actually covalently bonded, but they're missing an electron. Okay. So that's why the whole thing overall is a charge of negative. Oxygen has 7, hydrogen has 1. There's no way these guys can get enough to make them all happy.
Oh, okay.
So what happens is hydrogen is trying to share with oxygen, but oxygen is the electron hog, and it just sort of strips the electrons off of the hydrogen, and that leaves the poor little hydrogen slightly negative, or not slightly negative, slightly positive, while the oxygen is negative. that's why water, will bond the way it does, is cause the hydrogens are slightly positive, while the oxygens are partially negative.
So they're unhappy.
Yeah, they're unhappy, which is why they're a negative, which why they have to find sodium or something else to connect with to get the plus, so that now their share, at least their charge are equal, even though they can't share electrons. They prefer to be happy, but you know, world we live in is not always a happy place. Alright, are there any questions on this? Okay, so these guys are covalently bonded, however, they don't have enough, or they have, in this case, they have too many. Okay, makes sense? Plus ones are short an electron, these guys have an extra electron. Okay. Let's see. It's, assignment's on page
So
one
those are
ninety.
happy?
They will be happy once I put them next to a plus. Like, these guys will be happy when they have pluses next to them.
Okay.
There are positive cation ions as well as negative ones, just so you're aware, I just put the negative ones up here. Hydroxide is, what's in bases. This is cyanide, is in like the poison. So I don't know why that one always pops to mind, 'cause I guess poisons my brain, I can't get rid of it. And this one's always interesting. This one actually, we use in connection with acids, which is kind of interesting. Alright, so with that, it's page 190, 1 to 9. Oh, and just so you're aware, ionics are always formed between metals and non-metals. Just be aware of that.